So so we have learned how to solve order 1 and degree 1 differential equation, even order 1 and degree more than 1. So like in last class I have discussed Raoult's method. So next point is what about if order is more than 1, like this type of equation, d2 y upon dx2 plus xy equals 0. So this type of equation. Or maybe more order 3, 4. So, so how to solve these type of equations? Order is. Am I audible? My voice is clear.
Yes, sir.
Okay. Uh, and if you see means these type of equation, if you recall simple harmonic motion from class 12 and force also. So one dimension force is m d2x upon dt square. This is one dimensional force. Or if you see this simple harmonic motion, in simple harmonic motion, you have this type of equation. This what is there? So it's again means d2x upon dt square, and this is parallel to I think x, and you can see this d2x upon dt square. This we consider minus omega square x. So d2x upon dt square. So maybe you have seen these type of difference equation many times. This one. So how to solve this equation? Wait there. Okay. So today I will discuss about these equations. The order is order is So if you recall definition of linear equation, I will categorize linear equation into two categories now. So a linear ordinary differential equation, ordinary differential equation, differential equation of order n of order n in the dependent variable y, in the dependent variable and the independent variable x. And the independent variable x is an equation that can be expressed in the form of x dny dx plus a1x dn minus 1y dx plus an minus 1 x dy by dx plus an x y equals to fx. Okay, so this is linear equation, linear ordinary differential equation. We have seen it earlier in first or second class. So now I will categorize this linear equation into two forms. One form is fx equal to 0 and one form is fx is not 0. So when I say fx equals to 0, then that means this whole left hand side is equals to 0. So we call this linear equation is homogeneous linear equation. Okay, so this homogeneous and that homogeneous, they are different things. This is different type of homogeneous equation. And if this fx is some function of x, means it is not 0, then we call it non-homogeneous equation. So let's just try it. So where a naught x is not identically 0, is not identically 0, we shall assume that a naught a1 an and f are continuous real functions are continuous real functions on a real interval a less than equal to x less than equals to b, and that a naught x and that a naught x is non-zero for any x. For any x on a less than equals to x less than equals to b. So the right member the right member, fx is called the non-homogeneous term. Homogeneous term. If f is identically 0, if f is identically 0, if f is identically 0, so this equation, let me call it so equation 1 reduces to a naught x dny upon dxn plus a1x dn minus y upon dxn minus 1 plus an minus 1x dy upon dx plus anx y equals to 0. So if this fx equals 0, then this equation can be written like this. And this equation, this if we put equals to 0 on right hand side, then this is called homogeneous equation. And is then called homogeneous. Is then called homogeneous. But if it is not 0, if it is some function of x which is identically not 0, then it is called non-homogeneous. So for example, if I take just for n equals to 2. So basically in your course, second order differential equations are important. So that's why I'm taking this for n equals to 2. So for n equals to 2, this is a naught x d2 y upon dx2 plus a1x dy upon dx plus a2x y equals 0. So this is order 2 homogeneous equation. So this is said to be order 2 homogeneous equation. Homogeneous equation. Okay. So if you see, means here we assume that a naught, a1, a2 and f, a2 and f are continuous real functions. Are continuous real functions on a real interval. Real interval a less than equal to x less than equals to b, and that a naught x is not 0. and that element x equals 0 for any x, for any x a less than equal to x less than equals to 9. So for example, if I take this d2y upon dx2 plus 3x dy upon dx plus x cube y equals to e to the power x. Okay, so this is a linear, this is linear ODE of the second order. Second. Okay, and this is basically non-homogeneous also. Non-homogeneous. Why it is non-homogeneous? Because we have fx equal to x. Okay, so this is example 1. Similarly, we have example 2. So if we take d3y upon dx3 plus x d2y upon dx2 plus 3x squared dy upon dx equals to 5y minus sin x. So this is order 3. Order 3 linear equation, linear non-homogeneous.
सर एक सेकंड पीछे ऊपर कर लेना सर. डन लिख लिया सर.
So this theorem is about existence of solution of second order differential equation. Okay. So hypothesis and theorem is first, there are two hypotheses. Consider the nth order linear differential equation. The nth order linear differential equation. Linear differential equation a naught x dny upon dx plus a1 x dn minus 1 y upon dx plus an minus 1x dy upon dx plus anx y equals to fx. Where a naught, a1, an and f are continuous real functions. Are continuous real functions on interval a less than equal to x less than equals to b, and a naught x is not zero, and a naught x is not zero for any x on a less than equal to x less than equals to b. And second hypothesis is let x naught be any point of the interval, be any point of the interval a less than equal to x less than equals to b, and let c naught, c1, cn minus 1 be an arbitrary real numbers, be an arbitrary real numbers. So the important real numbers or real constant. So this a naught, a1, an minus 1, an, and this fx, they are real continuous functions on the interval, this interval. Okay, this is the important. And we are taking x naught be any point in this interval. Okay, these I will use later on. It's like this real numbers, or better if you write real constant. So now what is conclusion? Conclusion is there exists a unique solution f, a unique solution f of f of, so I'm calling this equation 1. Just copy paste of equation 1 of 1 such that fx not equal to,
सर 1 मिनट ऊपर कर लेंगे.
एक मिनट, fx not equals to c naught and f dash x naught is equal to c1 fn minus 1 x naught equals to cn minus 1. Means they are constant. And this solution is defined, and this solution is defined. This solution is defined for the entire interval. For the entire interval. A is then x less than. ठीक है इतना ही नॉट करके आप मुझे बताएं
नीचे कर दीजिए सर, नीचे कर दीजिए, लिख लिया है मैंने।
क्या
नीचे कर दीजिए सर, मैंने लिख लिया है।
So if you see examples based on this, consider the initial value problem. Consider IVP. IVP means initial value problem. d2y upon dx2 plus 3x dy upon dx plus x cube y equals to e to the power x. Why I am calling it initial value problem? Because I know the value of y initial. So y1 equals to 2 and y dash 1 equals to 5 minus 5. Okay. So if you see these coefficients, means what is a naught here? 1. And if you see this 3x and x cube and x cube. Okay. As well as this non-homogeneous term e to the power x. Non-homogeneous term. This e to the power x. They are continuous. Okay. So they are all continuous. So this is first condition. These coefficients, or if you see the first condition, where a naught, a1, an, and f are continuous real functions on an interval a to b. So if you see means the interval here, so this they are continuous 1 3x x cube everywhere. That means they are all continuous in minus infinite to infinite. Okay. So now what is next point? There exists a unique solution f of 1 such that fx naught. So this x naught here is 1. Okay. So here x naught is 1. And what is written then? Fx naught is c naught and f dash x naught is c1. So this is given here. Fx naught is 2 and f dash x naught is minus 5. They are real numbers, these 2 and minus 4. Okay. So thus the above theorem assures that a solution of given problem exists. Solution of given problem exists and unique. Given problem exists and unique. Okay.
सर सर ये थोड़ा ये समझा दीजिए सर, कंक्लूजन इस थ्योरम का कैसे हो रहा है, मतलब
देखो जो थ्योरम में ग्राफ, देखो यहाँ पे ड्रॉ करना इतना मतलब इस एग्जांपल के मैं ग्राफ ड्रॉ कर सकता हूँ, लेकिन इसमें तो यहाँ पर ग्राफ ड्रॉ करना इतना इजी नहीं, क्योंकि हमें पता ही नहीं है कौन से फंक्शन में क्या क्या
सर
इस एग्जांपल में
कैसा आया?
हाँ
x01 कैसा आया?
x0 देखो, आप देखो ना, हमें जो क्वेश्चन में गिवन है y1 की वैल्यू गिवन है, सो आप देखोगे तो x0 इक्वल टू 1 एंड 1 इन बिटवीन दिस माइनस इनफिनिटी टू इनफिनिटी. So if you see the statement of this theorem, the statement एक बार और देखेंगे, अच्छे से पता चलेगा. So consider the nth order linear differential equation. This linear differential equation where a0, a1, an and fx, f are continuous real functions on a interval a less than equal to x less than equal to b, and a0 x equals 0 not 0 for any x on a less than equal to x less than equal to. So this is given to us. Next point is let x0 be any point. Be any point. I think ये जो नहीं, ये जो interval ये यहाँ था. Be any point of the interval a less than equal to x. तो इस इंटरवल का ये कोई पॉइंट है, अगर आप देखेंगे सेकंड जो पॉइंट है x0 be any point of the interval and let c0, c1, cn minus 1 be an arbitrary real numbers. So what is conclusion then? There exists a unique solution f of 1 such that fx equal to this and f dash x not equal to this. So पहले तो हमने ये वेरीफाई किया 1, 3x and x cube और this non-homogeneous term ex, they are all continuous in minus infinity to infinity, and there is a point 1. So this point 1 in between minus infinity and infinite, and by these initial values fx naught would be 2 and f dash x naught would be minus 5. Okay, thus the above theorem assures that a solution of given problem exists and unique. Okay, that way out of the next is so there is a famous corollary of this theorem. Let f be a solution. Let f be a solution. Be a solution of the nth order homogeneous. Of the nth order homogeneous linear differential equation. Linear differential equation. A naught x dn y upon dxn plus a1x dn minus 1 y upon dxn minus 1 plus dot plus an minus 1x dy upon dx plus and xy equals to 0, such that fx not equals to 0, x not equals to 0, f dash x not equals to 0, and f n minus 1 x not equal to 0. So where x naught is a point of the interval, x naught is a point of the interval. Of the interval a less than equal to x less than equals to b, in which the coefficients a naught, a1 all continuous, a are all continuous. Okay, so this time I am taking homogeneous equation basically, such that this solution exists. So we are trying to find out the solution. So they are all continuous and a naught x is not 0. This is not a 0. So what is the conclusion then? Conclusion is then fx equals to 0 for all x on a less than equal to x less than equal to b. Okay, if it happens, then fx equals to 0 for all x. Means if all these fx naught and x naught 0 1 point, so this is 0 for f is 0 at 1 point, then it is 0. Because this x naught must be the point in between a and b. Let's take one example based on this. So if you take this equation d3y on dx3 plus twice d2y upon dx2 plus 4x dy upon dx dy upon dx plus x square y equals to 0. Okay, so it has a unique solution. Such that f2 equals to f dash 2 equals to f double dash 2 equals to 0. So this fx equals to 0, then fx equals to 0 for all x. So once we know the value of these are 0 at some 2, means this 2 in between some interval, whatever interval here. So that means fx equals 0 for x. Even if some interval is not mentioned, that means we are assuming it in minus infinity to infinity. Okay. Any doubt? So next, basically, I'm interested in this homogeneous equation. So the homogeneous equation. So
आप एक मिनट ऊपर कर सकते हैं एग्जांपल के लिए?
एक मिनट. So consider the homogeneous equation. Consider homogeneous equation. A naught x d and y upon dx plus a1x d and minus 1 dx minus 1 plus a n minus 1 dy upon dx plus a n x y equals to 0. This is homogeneous because this non-homogeneous quantity equals to 0. Okay, so let's say this is equation number 2. So let F1, F2, Fm be any m solutions. M solutions of the homogeneous linear difference.
सर ये बी एनी एम
हाँ
सर ऊपर क्या लिखा है आपने लेट f1 f2 fn बी एनी के बाद क्या
be any m solutions of the homogeneous linear differential equation. Linear differential equation 2. Okay, so these are solutions. M solutions. Then their linear combination C1 F1 plus C2 F2 plus dot plus Cm Fn is also a solution of 2. Is also a solution of 2. Solution of 2. Okay. So where C0, C1, Cm are m arbitrary constants. So what I am trying to say is
सर लिखा नहीं है ऊपर वाला अभी।
चलो बन लिख लो।
यस सर लिख लिया।
So basically what I am trying to say is, we take this example, d2y upon dx2 plus x is d2y upon dx2 plus y equals to 0. So if you see y equals to cx sin x, sorry, y equal to sin x satisfy this equation, and y equal to sin x is solution. Y equal to sin x is one solution of this equation. Okay, ये समझ में आ रहा है आपको? इसका सॉल्यूशन है y equal to sin x.
सर ये सोल्यूशन आया कैसे?
वो बाद में देखेंगे, पहले अभी आप ये
तो
देखिए, ये
हार्मोनिक मोशन जैसा कुछ है।
जस्ट वेरीफाई दिस इज सॉल्यूशन और नॉट। जैसे आपने एक ट्यूटोरियल भी किया था, उसमें वेरीफाई कर देते, वो हम लोग देखेंगे कैसे आया है। अभी तो पहले ये बता रहा हूँ कि ये इसका एक सॉल्यूशन है। हो गया? ठीक है सॉल्यूशन।
यस सर।
सॉल्यूशन सो बेसिकली y1 इक्वल टू f1x, अगर मैं बोलूँ इक्वल टू sin x is a solution of differential equation C3. Similarly, अगर आप ये चेक करेंगे y2 इक्वल्स टू f2x इक्वल टू cos x, ये भी इसका सॉल्यूशन है, आप चेक करिए। सो ये थ्योरम हमें क्या बताती है? ये बोलती है कि अगर ये दो सॉल्यूशन हैं इस तरह से, तो फिर इनका जो लीनियर कॉम्बिनेशन होगा C1f प्लस C2f2 which is C1 of sin x plus C2 of cos x. C1 C2 arbitrary constant है, ये मैंने आपको mention किया. So this is also solution of this differential equation. अगर ये सॉल्यूशन है तो इनके लीनियर कॉम्बिनेशन भी सॉल्यूशन है, आप चेक भी कर सकते हैं उसको. ठीक है? कोई डाउट है इसमें? आपने आप देख लेना, साइन एक्स भी इसका सोल्यूशन है, कोस एक्स भी इसका सोल्यूशन है, यू कैन वेरीफाई इट। सो फ्रॉम अबव थ्योरम, दिस थ्योरम से क्या आना चाहिए? C1 sin x प्लस C2 cos x, मतलब C1 F1 प्लस C2 F2। सो अगर आप वेरीफाई करेंगे ये भी इसका सोल्यूशन होगा, आप वेरीफाई कर लीजिए।
So we have another class. So sir, खत्म हो गया तो sir shall we leave?
सॉरी,
So we have another class. अगर आज अगर नहीं थे तो कुछ लीव कर दे।
क्या बोल रहे हैं?
सर मैं ये बोल रहा हूँ कि हमारी एक और क्लास है इसके बाद, ये अनदर क्लास, तो अगर आप यहीं तक पढ़ा रहे हैं तो फिर लीव करते हैं।
अच्छा अच्छा, ठीक है, हाँ, ओके, यू विल लीव योर क्लास, यस, यू लगता है मेरा नेटवर्क इशू है। हो सकता है मैं चेंज कर सर की स्क्रीन वीडियो है या नहीं, विजिबल है?